there! Now let's try a business application of calculus. CatsALot Cat Shelter is a cat shelter with a lot of cats. And because they have a lot of cats, they need a lot of food. Here's their current plan. Every year, they're going to make one order and they're going to buy all of their food. And then they're going to store it someplace. Is this the best plan? Is it best to make one order where you buy all the food? Or maybe you should make lots of little orders and buy less food each time? Who knows? Let's think about this. Because CatsALot has 30 cats at any one time, they need basically 70 bags of food for the entire year. And they're all 40-pound bags. It cost $10 in time and resources to make the order. They had to pay somebody to make the phone call. They have to have a phone bill. They maybe have to have some internet. $10. Okay. It cost $30 per bag. That's including shipping and everything. And it cost $10 per year per bag for storage. So you have to keep it someplace. You have to pay people to move them around. 70 bags of cat food, or however many you have, they have to. They take up space. So what's the cost? Well, if X is bags per order, so it's the number of bags per order, then at any one time, you're going to have X over 2 bags in your inventory, because the idea is you start off with all of them and then you go down to, so this is an average, that's the idea. And so storage cost is $10, so this is the storage cost. On the other hand, when you order, if you're buying X bags per order, then your one-time fee for the actual ordering is $10, and then it's $30 per bag, so it's 30 times X. However, for 70 bags, you have to make more than one order. If you buy them all at once, then you multiply by 1, so 70 over 70. But if you buy, say, 35 at a time, then you need to make 2 orders, and that would be 35. So this is the cost for ordering here. So now, the total cost of all this is going to be the storage cost plus the ordering cost. Now this is calculus class, and in calculus class we typically take derivatives. Now before I take any derivatives, the first thing I want to do is I want to simplify this equation. So what are we going to do? We're going to write C of x is equal to, that's 5x, and now I'm going to distribute this and see what happens. Let's see, 10 times 70 is 700, and this is all over x, and then 70 plus 70 times 30 is 2100, and the x's cancel here. So this is our formula, and this is something that we can easily differentiate. C prime of x is now equal to, let's see, it's going to be 5 plus, this is going to be minus 1 times 700 over x squared. There we go. And we can even simplify this down a little bit more. C prime of x is equal to 5 minus 700 over x squared. Okay, now suppose a former Calculus 1 student starts working for CatsALot, and they make the following claim. Our former student who was in Calculus 1 says, hey, if the number of bags per order is between 0 and what is the square root of 700 divided by 5? So the square root of 700 divided by 5 is 2 times the square root of 5. This is about 11.8 here. It says the number of bags per order per year is less than 11.8, then we need to increase the number of bags per order per year to lower cost. Why does this work? What's going on here? So a former student says that if x is between 0 and the square root of 700 over 5, which is around 11.8, then we should raise x to decrease cost. Well, why is this? Well, we should look at the first derivative again. We have that around, so we know that c prime of x is equal to 5 minus 700 over x squared. And we know that if we plug this number in for x squared, well, what's going to happen? We're going to square this, remove the square root. The 700s are going to cancel. The 5s are going to flip. We're going to get 5 minus this. So if we plug in a number x, and x is smaller than this number, then this quantity is going to become more and more negative, meaning we have 5 minus something that's more negative than this is when we plug in this number. So c prime of x will be negative. And this means that c of x, that's the cost, is decreasing as x increases. So we've seen that calculus can be useful in even a very trivial business application. Isn't that awesome? I mean, come on. Let's go do some more math.